like to do is introduce Wieslaw, Binienda, Dr. Binienda. He is a professor and chairman of the Department of Civil Engineering at the University of Akron. He is currently, Dr. Binienda also serves as an expert of the Polish government subcommittee for the investigation of the crash of Tu-154 at Smolensk, Russia on April 10, 2010, of which he is also a member of the equivalent today of the Polish NTSB, as I understand. Dr. Binienda received his Master of Science degree from the Warsaw Polytechnic Institute in Poland, Ph.D. in Mechanical Engineering from Drexel University in Philadelphia. His research interests include high-energy impact simulation, fracture, damage of materials with emphasis on advanced composites, explicit and implicit finite elemental analysis, smart materials, structural design, as well as optimization, characterization, and constitutive equation development of ceramics, metal, and polymer matrix composites. Wow. In 2010, Dr. Binienda was elected as the editor-in-chief of the Journal of Aerospace Engineering, and Dr. Binienda also serves as the co-director of the Gas Turbine Testing Center at the University of Akron, where he is responsible for impact material and structural experiments. If we could, please welcome the good doctor.
So, you know, coming to the crash of this airplane in Smolensk, I would like to show you the situation as it is described in the Russian report. So, in the lower picture, you can see the dotted red line that is given by in the Russian report, and yes, and somewhere here is a birch tree, and that birch tree was supposed to hit by this plane, according to the official report, at the altitude 5 meters from the ground. So to be more precise, I have the model of the airplane, and I'm going to pass it through. This is 1 to 200 scale of the same airplane that we are talking about. And this is in the same scale, the trunk of the birch. On this birch, there's a white spot that you can hold with your fingers. This is the ground. And you can see a place where they're supposed to hit the plane, this tree. The airplane was at 14 degrees, elevation, 14 degrees, angle, yeah. And hitting at that altitude, when I put it on the ground, it should touch with the wheels, and wheels were out, of course, because it was landing configuration, and the back of the aft part of the airplane should really trace the ground. Nothing happened like that. Moreover, if you can imagine that the airplane hit a tree, and according to the official report, the tree sheared off 1/3 of the wing. This is 18-meter long wing, and the tree sheared off completely 1/3 of the wing. So after that, you know, airplanes don't have 1/3 of the wing, and is flying, as you can see, 80 meters per second. So basically, between the green and white line is about 1 second. Okay, so to give you the imagination. So this plane is going down, and somehow is changing its orientation. Is flying up now, then going straight again, going up like. And if you calculate the accelerations, because acceleration is change of the velocity in time, it means that the passengers and pilots and airplane would feel in this location about 10 Gs of acceleration. Of course, the plane this is equivalent to Boeing 727, would not be able to withstand 10 Gs. Okay, if you have 2 Gs, maybe, but 10 Gs, that would be structurally impossible. So this airplane should disintegrate at first moment of 10 Gs. that would be able to see. But moreover, it is impossible to get these 10 Gs on upswing. You know, even F-16, you cannot get 10 Gs by flying up. Okay, you can maybe going on the corners, but not flying up. This is physically impossible. The black line is the information of this from the TAFS report. TAFS report it was sent to United States to Universal Avionics, and it was read in the United States. This is the only information that was read in the United States, and it is in a quite big disagreement with the red dotted line. The trouble is that if the plane was flying according to dark line, the black line, it never hit the tree because it was about 15 meters above the tree top. So now why they had to make this plane to go to that eventually the same altitude? Well, because in the next statement of the Russian report, the plane is making upside down rotation. So if it had lost 6 meters of 18 meters long wing, they had to allow this airplane to go up in order to make the rotation, right? Because if it would start rotation before, it will hit with the ground with the wing, right? So then you can ask yourself questions: is it physically possible? So I let you examine the tree and the airplane and continue my presentation.
Sorry, can I ask?
Yes.
Can you say a little bit more about the black line? Why was that sent
This one?
away for analysis?
Yes. Why it was what?
Why was that sent to America for
Well,
analysis?
because this device, TAFS device, is Universal Avionics device. So Russian could not read it.
Which device is that?
Terrain Awareness Warning System.
Oh, the TAWS.
TAWS, T-A-W-S.
So it had a universal TAWS system installed?
That's correct.
Okay.
That's correct. So they were able to open their own black boxes that were put on this airplane. There was ATM black box which was installed from Poland, and it was sent to Poland to be read and then returned to Russia. This TAWS device was sent to United States and returned to Moscow. So everything right now they are in Moscow, but at least it was read in United States. Okay, so now if you look at this, this is horizontal. You know how we can see the flight from the top down. This is the birch tree, and this is the center of mass of this airplane. So the distance between the birch tree and this black line here is about 12 meters, because 18 meters span, 6 meters cut off 1/3 of the wing. So you can imagine what it is here. Now this wing is found here, so about 110 meters from the location of the birch. So somehow, according to the report, the tree cut out 6-meter wing that was of the airplane that was flying 80 meters per second, and that wing was able to maneuver through trees and bushes and everything else and landed 110 meters away without touching anything, not making any scratch of any tree. And in fact, the airplane also, as you can see, this is this is whole forest here, and somehow was able to hit the tree in the inside of the forest, but not touching any other tree. So that is also questionable how come that is physically possible. But anyway, the airplane was flying straight, as you can see according to the Russian report, and somewhere here it turned suddenly about 20 degrees left and hit the ground somewhere in this area, and this is the location about 30 meters above the ground where all the electricity, everything was shut down, FMS and everything was shut down. So this is the last moment of recording of the information from black boxes. So at this, according to the Russian report, at this moment, airplane was 30 meters above the ground. So what happened? That was not ever explained. Okay. Now, if we look at the area of the disintegration of the airplane, this is the location of the first marks of the airplane to the ground. There are only a few scratches, about 40 centimeters wide, 40 centimeters deep, and several meters long, as you can see here. The whole airplane is integrated with 60,000 of pieces. To give you an example, the in Lockerbie, Panam was destroyed by a bomb and into 10,000 pieces, and they found all 98% of that. We visited TWA yesterday, and to my knowledge, it is about 6,000 pieces that this airplane disintegrated to. And also, I heard yesterday that they found 95 or 98% of the pieces, and they reconstructed, as we could see yesterday. Here in Russia, you saw the video of destruction of the evidence, and this is the 11th of April, the day after. This is 2 days after of the two satellite pictures. And same part, you can see traveled overnight from one spot to another. Well, we asked Russia why they moved those parts. Moreover, in the report, if you find, because they could move it, they could record their position and take pictures and move wherever they like. This is according to standards. But we found in the report that the position is this one, which is much closer to the touching the airplane ground than it was here. They said, well, it was basically some bystanders were trying to steal aluminum, and militia was running after them, and they dropped it. Okay, so that was the explanation. Trouble is that this piece weighs about 400 pounds. So I cannot imagine that somebody just pulling 400 pounds piece of aluminum and running away, and militia is running after them. So there's a lot of questions, a lot of problems that of violation of standards that we know as they are.
Sorry, and these photos are from?
These are from satellite pictures that you can buy, from commercial satellite pictures. Basically, they are available. We paid $100 for a picture when we have it. So we obviously, to see what is going on, a lot of people suspected that something is not correct. And you can buy those satellite pictures from Google or equivalent Google Earth places anytime.
So it's commercial.
They are commercial. Now I have to mention here that this government is very helpful. So I cannot tell you details, of course, but we have much better information than I can show you because they are part of the investigation. But I have to acknowledge the U.S. government for the help that is providing us with on every aspect. So myself as a professor, I decided that it is a good topic to educating graduate students using the highest technology that is available right now, the top technology, which is finite element explicit calculations that we in fact use for Columbia disaster. This was the same methodology that we used for Columbia disaster, developed by Aerospace consortium that I am part of. The consortium was not, of course, created for Columbia disaster or for any airplane disaster, but it was created by Boeing and jet engine companies to help in design purpose to accelerate the new products to market. And part of this consortium are all the airplane jet engine companies, many universities, and we work with them. Now I wanted to show you again, this is that 60,000 small pieces. Not only that they are 60,000, but they are very small pieces. One of them is shown here. This piece was way before this airplane hit the ground. So, of course, it was explained by Russia that the plane disintegrated in the air because of this birch tree. Not only the tree hit the wing and and created the problem that it sheared 1/3 of the wing, but basically the whole airplane disintegrated because it became like brittle material. It is, they say, well, obviously at this speed, 80 meters per second, airplane is very brittle and it breaks on contact with any branches of any trees and anything else. So even though the plane was flying another 300, 400 meters, but it left a lot of pieces along the way before even hitting the ground. So one of the experts from Poland looking at this particular piece found that this is typical example of explosion. The size is small, and the higher the energy in explosion, the smaller the pieces you have from the airplane or frame. These are called shrapnels, basically. It's like a grenade. And you have the typical shape of internal pressure what is nice about aluminum, that a snapshot, it preserves the state at the maximum deformation. So you can see those pressure that is pushed this piece, and this is piece of the wing outside. You have dark parts inside and shiny outside. The dark is because of high temperature inside. And you have rivets that are pulled out. Rivets work in shear. They are not working in tension. So if something is pulled out, it means that you have to have normal pressure, not shear pressure as one would expect in crash into some valleys, other valleys. So another researcher from Denmark looking at the situation, he found all those, this is the location of the crash into the ground. But you can see all these parts of this airplane all over. Even this is the location of the so-called verge. But first parts are way 70 meters before the verge tree. So they were never explained. And this is, we know about them because we have that good help, and which I cannot talk about. But anyway, this is those pieces, that are basically evidence that that the tree has nothing to do with this. And a lot of parts around the tree, so you can imagine that if they fell to ground and they hang on the other trees, on the top of other trees, that means they were flying with that velocity and eventually slow down to hang on the piece of other trees and other, so you have all this weight. But he was focusing also on the change of vegetation color, discoloration of the vegetation in the satellite picture. A couple of this is the April 10, and the picture is from summer, which is 1 month later. So April in Russia is springtime, so this is where the vegetation wakes up. And he found that there are 3 discoloration in the typical shape that one would produce by spraying fuel. And we know that in wings we have fuel. So there are 3 instances that this spray is coming. And one is before the tree, second is around the tree, and third one is the location where the plane changed its orientation. So this is where can be correlated to a big push, some energy push that changed the orientation from a straight line to going 20 degrees left.
Did anybody do any testing of the soil for hydrocarbons?
Well, again, nobody was allowed to go to Russia to do any testing. So we have to rely on the things that we have available. In fact, what we propose right now, that we should come right now to Russia, 6 years later, and still do those tests. And so far, Mr. Putin did not agree with that request. So this is the tree in question, and this is the part that is hanging. You can see that the good thing is also that there was a lot of journalists waiting for this presidential visit, And when the crash happened, all of them, just like a big uncontrollable group, went to the crash and took pictures, millions of pictures. So, and then they posted them on the internet. So we collected several millions of pictures from every angle of every spot, which is the accidental, well-documented area, which is not produced by Russia, but it is produced by journalists who just took pictures for their own sake.
Could you explain what caused the damage to that tree that's being shown in the picture?
So the tree, if you would look closely, has a typical break. This is bending breaking. This is not cutting through the wing. Okay, this is not. On the first day of the crash, this part was hanging, in fact, on the top. It was later on pulled by somebody down or by its own weight.
So it's not crash related?
This is not, has nothing to do with the crash, no. It may be broken due to air of the low-flying airplane. Okay, just like the turbulence that can produce that. But I'm not speculating anything. Okay, I'm open-minded person. So another professor from Jorgensen from and Kowaleczko from Poland and Denmark, they did calculation of aerodynamics. So using the information of from the black boxes that were copied from the black boxes and given to Poland, he calculated what should be the loss of the wing in order to produce the rotation, upside-down rotation that was recorded by black boxes. So based on the aerodynamics, if you shear off 6 meters of the wing, and wing, as you know, is trapezoid, it's not as wide at the tip as it is in the front, so you are not losing 30% of the lift force. You are losing about 10 to 12% of the lift force only. Especially that the pressure is not uniform for the whole wing, it's kind of sinusoidal, just for the simplicity. So when you shear off 1/3 of the wing, basically pilots can continue adjusting their ailerons and continue flying straight. Or at least, mitigate the loss of the lift force. In fact, Boeing people told me that airplanes are designed for 20% difference in lift force due to burst of the wing. So, in other words, the pilot should be able to control airplane as much as 20% difference in the lift force. Of course, this was not Boeing, it was Tupolev, it was copy of Boeing 727, so maybe it was not as good, but at least, we in the general sense, we suspect that 1/3 of the wing would not be enough. And he calculated based on the computational fluid dynamics calculations. In fact, he used a company that is working for Boeing, and they established that they had to be 2/3, so not 6 meters, but twice as much loss of the wing in order to produce the rotation according to the black box. But if you lose 2/3 of the wing, in order to fall, and this is the location of the fall, the first touch of to the ground, the airplane must be much higher than it could be to hit the tree. Okay, so basically, no matter what you do calculations to be even not exactly at the location of the breaking of the tree, and so many meters away, because also unfortunately for this case, this is like a valley, and the location of the fall of the airplane is at the higher elevation. So there's some difference in as you can see, between the tree and that position. So anyway, for those debris to fall in this location where they should, the airplane is about 30 to 50 meters, which confirms, by the way, this TAWS measurement. So this is completely independent, done using the aerodynamics calculations, and this is what it happened. So, you know, the airplane is made of aluminum, as we know. And we remember World Trade Center when the aluminum airplane hit the World Trade Center and cut the shape of the plane, and those vertical lines which you can remember on the outside of the World Trade Center were made of steel, not birch, but made of steel. And steel is much tougher, much stronger than aluminum. So it happens that experiment shows that with speed of the airplane, it is possible to have situation where the aluminum wings can cut through the steel columns, as it was shown in World Trade Center. So we, together with other professors and researchers from NASA, FAA, we focused last 10 years to characterize aluminum 2024 T351, which is used for wing of the airplane. And if you would go to school some time ago, you will know that aluminum is elastic plastic material, and they will give you a curve as it was from the school to maximum strength, to maximum strain. But aluminum is a very interesting material. It behaves differently if it is under unidirectional state of stress or if it is under multi-directional state of stress. Now, although this is thin-walled tube type of material, which means it is a skin of the wing or the fuselage, but during the crash time, this material is under combined load. It is under tension in both direction and compression in third one. So the strength, this is the so-called surface of the strength of aluminum. We put a lot of tests, as you can see here. A lot of universities contributed to that and characterized this material very closely. And now we are able to use this characterized material as it is done by state-of-the-art in LsDyna and simulate the events as we wish. I want to come back. Okay, so one thing I did a test using gas gun. This is the gas gun in my laboratory, which can accelerate the objects to velocities up to speed of sound. So I use this from this same material, which is used for airplanes, the structure of that shape, and even at 300 meters per second, which is more than 4 times velocity of the airplane in Smolensk, the material is not disintegrated to any pieces. It is, as you can see, this is the before crash to the steel wall. This is after crash to the steel wall. It is very plastic. It is fracturing, is curling as you can see here, but it's not producing any shrapnels. It's not flying any components. So material is not brittle, and it should be, because if we have bird strike, and if you have bird strike, then you will have the whole airplane break it into pieces like piece of glass. That would be bad, okay? We want material to absorb the fracture and not to break into many shrapnels and many pieces. So, not knowing a lot of things, we did it with my students, with graduate students who got PhDs and master's degree, studies, so-called parametric studies. We change velocities, we change different orientation of the airplane, but we use this material model, which is in comparison, this is the stress-strain curve of the aluminum 2024 T351 in comparison with birch. The steel would be much higher over there, okay? So in the World Trade Center, this material, which is characterized by those two curves, which is strain rate dependent, was able to cut through the steel, which is 3 times higher than aluminum. And this is the birch. The toughness of the material, the energy that is needed to fracture material into pieces is area under the curve, okay? So area on this triangle and area under this black line, I don't need to prove anything that it is one, this is much smaller than that one, right? So you can say that yes, the material is much weaker. So I will show you the simulation. This is the simulation of this airplane that we built basically in finite elements with state-of-the-art for the materials characterization. And what happened? We can see that the airplane cuts through the birch tree and still has the wings, as you can see, in good shape. Let's look at the closer. Of course, there's a damage to the leading edge. Okay, this is where the material is very thin, and but the spar, first spar, is solid enough, and we saw those spars yesterday in Boeing 747. They are pretty strong, and they are able to cut through this wing. Imagine that the whole event of cutting through this is 0.099 seconds. So this is very fast. Some airplane is flying 40 meters per second. So this is like a explosive. Okay, basically the tree is feeling the explosive pressure. So conclusions are obvious that the tree has nothing to do with the wing damage. I wanted to mention that there was FAA tests using airplane Constellation, and yesterday in museum there was that airplane, I saw it. The Constellation airplane is old airplane with 4 engines, the propeller engines. It is about half of the weight, half of the speed. So you can imagine that wings are much weaker because the wings are what holds the mass and speed of the airplane. And Professor Kocheri from California did similar work as I did it for this cupola, using this FAA experiment where the airplane cut through the pole, electric pole. As you can see, the electric pole is in pieces flying after this airplane. And it is experiment, and it's even 100%. So it's not just my work, but other people's work that confirm those same results. Now, yesterday we saw a reconstruction of the important part of the airplane in the hangar. Well, Russians never did it, okay? So what we did it, we reconstructed on paper. We found all pieces from those millions of pictures and tried to find what we could identify, what we couldn't. And we were able to identify all pieces, and the critical is the leading edge. I don't know if you remember, in my simulation, the leading edge showed disintegration or contact with the tree. It was 60 centimeters to 80 centimeters, basically, a removal of this front leading edge. Now we found undamaged or slightly damaged slats of the leading edge, so there is no any contact with anything. If they are sitting like that, we are not damaged, not bended, not broken, not crushed. However, there is a big hole in the center part of the wing. That correlates, in fact, with calculations of the guy from Denmark about bigger loss of the wing. And obviously, if you remove this material from that part of the wing, this will fly away, okay? Because there's nothing to hold, okay? So that has nothing to do with it. What else we can see? This is the one part of the fuselage that is indeed upside down. This is the bottom of the airplane. There is a floor where the chair is supposed to be connected. And one side of the airplane and ceiling is on that side, and the other is on the other side. Well, to me, this means that the airplane had to open before it hit the ground, because only then you can have both sides outside of the floor. If it is going to be happening by crashing the one part, either one wall or the other wall or ceiling, would be under the floor, not outside the floor.
How's about rebound after the fuselage strikes the ground, rebounds up, and you have this memorization, and you have this expansion on both sides? Could that not happen?
No, because the area was very soft soil. It was like wet. People, if you look at the videos, people walking on it, they sank in the soft, wet soil. So basically, it was just like in a mat. It was hitting the mat and staying. It was not bouncing, especially part like that. The length of that part that I showed was 20 meters. So it's not something that it could bounce easily like here. But I did also calculations when according to the requirements of MAC in Russia, what will happen if the whole airplane, 80 tons airplane, flies into ground with a velocity 80 meters per second, right? Because this is what they say in the report. So, not knowing the angle, I use 30 and 10 degrees, again parametrically. This is what how the airplane disintegrates at wheels down position. And it was interesting because this simulation was done way before this experiment was done on the same similar airplane, Boeing 727 in New Mexico. In United States. And here, of course, there are no passengers inside. I think you know this experiment, right? So this is just a reminder. The airplane hits the ground with higher velocity, in fact, vertical velocity, and than it is according to the MAC report for Boeing 727. And this integrates also to 3 pieces, which confirms my simulation perfectly. So I was very happy because my simulation was before this experiment was done, and it was presented at the conference. So, moreover, they had dummies inside of this airplane, and they put accelerometers on those dummies, and they found that most of the passengers in the middle section and aft section would survive this crash. Of course, people in first class and business class may not. Okay, so you may want to think about how you're flying. I did, having that model confirmed, I was able to do upside down, and of course I can see that also I could measure the accelerations inside of and fuselage damage. In fact, it is likely that a number of passengers should survive even in that configuration. And this is the simulation. But more than that, more the damage to the airplane is interesting. The damage to the ground. I said that this was soft ground. So one would imagine that an airplane that's flying 80 meters per second, and you have Newton's third law, which is action is reaction. So it means there must be some traces, significant traces or craters on ground, soft ground. And I could measure what would be those, how deep and how long they should be. Depending on, of course, on the angle of the strike of this airplane. So this one was much significant, more damage to the airplane, deeper craters. So this is all. This is it. What it is. Okay. This is 40 centimeters deep. This is nothing. Okay. There's no any crater in this ground. Okay. So the only way to explain why there's no crater is that instead of one mass of 80 meters per second of 80 tons hitting the ground with 80 meters per second, there's a rain of small pieces falling down after the airplane was disintegrated in the air. There's no other physical possibility. Okay, if it would hit as one mass, you should have this type of shapes, traces on the ground. Like you can see part of Panam in Lockerbie, or the lake produced by Value Jet 592 in Florida. Other exampos of airplane that hit the ground. This is Sioux City, Iowa. I'm sure you remember that. It was looking very dramatic, but still 178 passengers survived this very dramatic hit to concrete ground, and landed upside down. Also, there was a lot of fire. But what is interesting that even people who died, you could see them as they look like people. All victims in Smolensk were naked, were the somehow the clothes were ripped off from them and they were covered in kind of gray substance. Seats, you can see seats in good shape even in that particular crash. All seats were completely disintegrated in Smolensk. So these are important. Other of similar crashes without explosion, you can see people survive. And this is comparison of Russian reconstruction of the airplane. Okay, this is following the ICAO requirement of Chicago Convention. This is how they did it. They just dumped everything in one place. In fact, even some of those parts on the left wing are from the right wing. And what is interesting, however, that right wing is also disintegrated to pieces. There's no information about hitting any trees or anything else, but it has the same type of damage as the left wing. So I will leave it with that. Thank you.
Well, I have to say that and it has been very interesting to say the least, and thank you very much, Doctor.
And I can say my students love this work because this is a real story. And I didn't do all of this work. These are done by students from India, from China, from America. Right now they are working for American students. They are working for NASA, NASA Langley, NASA Glenn research centers. They get best education.
That's very good. So thank you again. Any questions before we break for lunch?
I'm just curious, where is this going?
Well, right now, as was said, this work, which was done for the sake of education, this was done for the sake of, whatever I showed you is pure education, pure research. It's done with exactly the same way as we investigated Columbia investigations, or we use it for jet engine containment. This is what it is. Now, I'm part of the commission, and commission is going to review every information, all evidence available. We will ask Russia to return to Poland the wreckage and black boxes. If they would agree, and I hope under pressure, international pressure, they will do that, then we can look at the evidence more closely. And we are trying not to make conclusions, because really it's hard to make conclusions without evidence, right? Even using the knowledge that I presented. But obviously, no conclusion can be accepted if they violate the law of physics, law of Newton's law, or material behavior, okay? That cannot be just accepted like that, need to be explained. So if some people say, well, maybe that material that was the aluminum, Russian aluminum, is not as good as American aluminum. Okay, well, we have to test it and we have to compare. Okay, most likely this is not the case. Just to give you an example, this Tupolev, which is compared to Boeing 727, is much heavier than it is the Boeing. Boeing has only 2 spars, and Tupolev has 3 spars. And the reason is that they made it for same airplane to be carrying much more loads, so it can be used as a bomber, okay, not just passenger airplane. So this is a very heavy-duty airplane, okay, much heavier than Boeing. And Boeing's cut through the World Trade Center. Sorry for this experiment, but this experiment. And how you can explain that the aluminum is cutting through steel, not one steel column, but many of them, 20. And yes, later on exploded and hit the core and disintegrated. But you can see the shape of the airplane as it entered the World Trade Center. And one tiny birch tree is completely cutting the airplane to pieces, okay? That's basically hard to explain.
We have time for maybe one other quick question, and then we're going, Bobby, quick question?
Yeah, how much, by law, does the International Civil Aviation Organization, how much power does it have with so many member states to drive the legal aspects of this?
Well, I will need to leave to my wife.
Yeah, I would imagine it's probably
No,
more.
because it's not under their jurisdiction.
Well, then
It's
what is?
outside of their jurisdiction.
It's a treaty agreement.
Yeah.
It's not a civilian.
Because it's a military airplane, state
Okay.
airplane.
Yeah, state airplanes are.
So,
Quick question.
But just to
Oh,
May I
no.
just speak to that point? In May of 2011, Senator Richard Burr, who was then a member of the United States Senate Intelligence Committee, Republican of North Carolina, today he's the chair of the United States Senate Intelligence Committee. He sponsored a sense of the Senate resolution calling for an independent international investigation of the Smolensk disaster after he, Senator Burr, met with Antoni Macierewicz, who's now Polish Minister of Defense. Then Macierewicz was head of the commission investigating the Smolensk disaster.
Well, I think the analysis that the doctor presents is certainly a compelling, is certainly compelling information as to what on the surface exists to warrant possibly looking at it further, but it certainly is representative of a very thorough analysis. But that's, you know, we can go on from there forever, I believe, so I think we should probably step where we are right now.
I just want to add that for families, this work was very important because they get no answer from official government reports, and they at least no attempt to answer to get some explanation.
Right.
We'll see. As time goes by, I think we'll all be interested to follow it and see what happens as time progresses and let the chips fall where they may, so to speak. Let's go ahead. It's